Okay, we've never encountered one like this before, but I wanted to show you one because it's interesting. Okay, normally I told you that when it starts off exponential, we go to a logarithm, and technically this is a very wacky exponential problem because we have exponents on both sides that have variables in them. So we're going to have to do something crazy. What we're going to do to start this problem, instead of trying to convert it into a logarithm, we're going to do the same thing to one side that we do to the other. We're going to take the log of both sides. So the log of this side and the log of that side. It is perfectly legal. So the next step is going to look like this. Log of 27 with that ridiculous exponent equals log of 9 to the 3x, that ridiculous exponent. Now, if I could digress for just a moment here, one of the properties of logarithms that you're going to need to remember is that whenever you have, I'm going to make this up, this has nothing to do with the problem, but whenever you have a number in the front, like 2 log of x, it is perfectly okay to take that 2 and move it up front and it becomes log of x squared, right? Well, you could take that 2 and put it back in the front and you wind up exactly where you started. And we're going to need to do that for this. So what we're about to do is take that and put it in the front. And we're going to take that and put it in the front. So the very next step is going to look like this. 4x minus 14, all one big quantity, times the log of 27 equals, 3x comes out front. We'll put it in parentheses just to make it look pretty. Log of 9. Whoa, where in the world are we going to go from here? Well, let me tell you. We have a couple messes. They're going to be ugly decimal messes, but we're going to fix them. We need to know what these values are. There's more than one way to do it, but I personally feel like that's the quickest one. So we're going to do that. Let's find out what the log of 27 is. So we type it in our calculator. I got 1.43. So we have 4x minus 14 times that value, and that ended up being 1.43. And that's equal to 3x times the log of 9. Log of 9 is 0.95. Now there's going to be a little bit of error because we've rounded, but that's okay. All right. So what we need to do is distribute. We're going to distribute over here. We're going to get some crazy decimals, but we'll be all right. We're going to multiply those. We'll be all right. It's not going to kill us. In the words of a great poet, what doesn't kill you makes you stronger. If I knew the rest of the words, I'd sing them, but I'm not going to torture you. Instead, I'm just going to multiply. 5.72x, 14 times 1.43, we get 20.02, and that's equal to 3 times 0.95. Should know this off the top of my head. That is 2.85. Okay, we're going to solve this. Notice at this point there is not a single logarithm in the whole thing. Everything is taken care of. All we have to do is just some basic algebra. So let's keep going. We are going to subtract 5.72x from both sides so we can get all our x's over here. So minus 5.72x on both of those. There we go. So we have negative 20.02 equals negative 2.87x. At this point, we're just simply going to divide. We'll pull out a different color pen just to show we're doing something different. Negative 2.87x. Negative 2. My handwriting got really sloppy all of a sudden. Whoops, oops, oops, oops. Not going to divide by x. My bad. Sorry about that. 20.02 divided by 2.87. We know it's going to be positive, and we end up with a beautiful answer. .98. That is awfully close to 7. I'm starting to think that the answer might actually be 7, but there was some rounding error in there. Let's see. to tell. All right, here's our answer. If you want to round that to 7, I would not be offended.